So let's take an additional look at compound events, probability of compound events. And remember, a compound event is simply an event that is made up of two or more events. So I have a couple of examples here. Chewing gum and eating eggs, different separate event. Being on a basketball team and making a basket during a game, two separate events. And we talked about independent and dependent events. And now we're going to talk about mutually exclusive and overlapping events. So independent and dependent were kind of like the opposite of one another. And mutually exclusive and overlapping, they're also kind of the opposite of one another, and they have different rules. So mutually exclusive events, like it sounds like, are two events or two or more events that cannot happen at the exact same time. For example, I can't roll a 5 and a 1 on a standard die at the same time. In this case here, I ended up with a 3. I can only roll a 3. I can't roll a 3 and a 5 or a 3 and a 1 on the same roll. Those would be mutually exclusive events. I can't fly in an airplane and stand on the ground at the same time. I can't swim and climb a mountain at the same time. Those are examples of mutually exclusive events. Overlapping events are events that have some outcomes in common. So here's an example, again using a die. I can have an event of rolling an even number and the event of rolling a multiple of 3. Those can overlap. Because if I pulled a 6, that is both an even number and a multiple of 3. If I had a standard deck of cards, I could select a king and a red card because they overlap. I could select this king right here and I could select that king right there. Those are overlapping events. So let's start with a couple of rules for mutually exclusive events. So that's right here. Mutually exclusive. And one rule is that the probability of event A happening and event B happening at the same time is 0. That's almost the definition of mutually exclusive, is I can't have A and B at the same time. Now, I could have the probability of event A or event B. I could be mountain climbing or swimming. Or I could roll on a dice a 6 or a 3. And the probability for that, that's our addition rule. That is equal to the probability of event A plus the probability of event B. So let's look at an example. So at some school, student athletes may participate in only one sport each season. So there's a fall season, and we find that 28% of student athletes play basketball. That is our event A. And 24% of student athletes are on the swim team. That is our event B. And I want to know, what is the probability that if I just select a student athlete at random, what's the probability that they're on the basketball or on the swim team? I mean, they could also be on, I don't know, what other sports are at the same time. Maybe they're on the hockey team, a student athlete on the hockey team, or the rugby team, or some other kind of a team. I want to know, what is the probability that if I just go into my pool of student athletes, that I'm going to select someone that is either on the basketball team or the swim team. Those are mutually exclusive. You cannot be on both. So I could write the probability of A and B, playing basketball and on the swim team, is 0. Nobody's allowed to do that. And if I want to find out what is the probability of playing basketball or on the swim team, well, then I have my probability of A plus my probability of B, and that would equal to 24% plus 28% equals, well, there's a 52% probability that they are either, that my student athlete is either on the basketball team or the swim team. Let's just see if we can make a little graph to show you how that would look. So here, this is 100% of all the sports. So that is my sample space, is all sports teams. And I know that I have, 28%, what was it? 28% are basketball, and 24% are swim, and the rest are some kind of other sport. And we know that would be the complement. We learned that the last one. So that would be 48% is that. And you can see really pretty clearly how basketball or swim makes up 52% of all the student athletes. But what if I have overlapping events? What if students were allowed to play two sports? And we know that 28% of student athletes play basketball. And we know that 24% of student athletes swim. But what if we also know that 10% of student athletes are on the basketball and the swim team? So we have some overlap. Some students are playing only basketball. Some students are only swimming. But 10% of the students are on the basketball team and on the swim team. Well, that changes our probabilities also. So if I went back and readdressed our question is, what is the probability that a randomly selected student athlete plays basketball or is on the swim team? And I've changed the rules now. They can participate in two sports. I still want to know what is the probability that I go and I pick a student athlete that they're going to play basketball or on the swim team. So here are my student athletes that play basketball, and we know that that's 28%. And here are my student athletes that swim, and I know that that's 24%. But I know that there's an overlap in here of 10%. And so I can't just add the two together, because then I would be double counting this 10%. If I added 28% and 24, I'd get 52%, but 10% are doing both. So, whoops, sorry, that's 10%. And I don't want to count them twice. So that leads us to the addition rule when I have overlapping events. So now I'm looking at the probability of event A or event B. Well, that's equal to the probability of A minus plus the probability of B. So it looks very similar to what we had before. But I have to subtract the probability that a student is doing both A and B. So what I have is I have the probability of A, which is 28%, plus the probability of B, which was 24%. So that's our 52%. But I have to subtract the probability that a student is doing both. I have to subtract 10%. So it tells me that 42% is the probability that if I went and I selected a student at random, that they would be on the basketball team or on the swim team. Let's just look at it on a picture to try and just make sure we understand this. So here's 100 students. So I'm going to say it's a class of 100 students that we can do our percentages easily. And we know that, let's call it, the green is the the basketball. And let's call red for swim. Excuse me. So I know I had a 28% play basketball. So that would be, each row is 10. So 10, 10, 20, and then 8. So I go, this group right here are my basketball players, and then 24% are swim. So I have this row of 10 and that row of 10, and I'm going to add these two and those two to get me 24% of our swimmers. And you can see that I have 52%, a row of 10, 20, 30, 40, 50, and then those two. So that's my 52%. That is when they were mutually exclusive. They were only allowed to play one sport. Well, let's take a look at it if they're allowed to play two sports. So I still have my 28% of swimmers, but I've also been told that 10% of the student athletes do both swim and basketball. So that means 10 of these 100 do both swimming and basketball. So I'm going to go into my basketball pile here, and I'm going to mark 10 of these, 2, 3, 4, 5, 6, 7, 8, 9. 10 of them are swimmers. And we knew that our basketball had 28, and that our swimmers had 24. Well, I've already marked off 10. I got to mark off 14 more. So I'll take these two, those 10, and then another 2 right here. So now I'm marking off all of my just swimmers. I have my just swimmers. I have these people right here who do both. And there's 24 of those. And you can see that I have, well, 10, 20, 30, 40, 42, which was exactly the number that we had when we did it on our calculations with the formula. So this is a very important formula for compound events that overlap.